lecturer, Department of Civil Engineering, Presidency University. Thanks to Indian Concrete Institute to organize an international symposium on innovative wall of concrete 2024. My research topic is an investigation into the compressive strength of concrete using demolition waste as an partial replacement of coarse aggregate and fine aggregate. There are two co-authors, Dr. M.D. Sultanul Islam and M.D. Omar Farooq Kolkata. My presentation will contain these topics: introduction, literature review, objective, materials, methodology, resultant discussion, conclusion, recommendation. Introduction. Concrete is a composite material composed of coarse aggregate, fine aggregate, which is bonded with fluid cement that harden over time. And it is the second most widely used material in the world after water, and is the most used material of building materials. On the other hand, the generation of demolition waste is increasing day by day, and it is significant and it is very threatening to our environment. So, if we can recycle this demolition waste, it can be a better solution for our environment. So, for recycling this demolition waste, we can use this as a partial replacement of coarse aggregate and fine aggregate. Here we consider only the compressive strength, which is a most important character of concrete. Literature review. Here, in 2020, Duan et al. And others found that the replacement of coarse aggregate by recycled coarse aggregate about 30% does not affect the compressive strength. But after this percentage, if we increase the percentage, then the compressive strength decreases. On the other hand, in 2018, Marian et al. And others researched that when we use 20% of demolition, 20% of recycled material instead of the fine aggregate, then the compressive strength does not affect. But if we increase above this percentage, but 20%, then the compressive strength is affect. Then Vikas et al. 2015 found that 30% replacement of coarse aggregate and 10% replacement of fine aggregate of demolition waste is optimum considering the compressive strength. Objective. The specific objective of my research is to investigate the compressive strength of concrete by partially replacing the coarse aggregate by demolition coarse aggregate, to investigate the compressive strength of concrete by partially replacing the fine aggregate by demolition fine aggregate, and last of all, to find the relevancy of my research with other research work and find the optimum percentage of demolition waste replacement considering compressive strength. Here the material: Portland composite cement, freshwater, natural coarse aggregate. Here I use brick tips. Demolition coarse aggregate. For demolition coarse aggregate, I mainly use the foundation of a building. Natural fine aggregate, which is sand, silt sand mainly. Demolition fine aggregate, which is also the foundation demolition waste. Here this table shows us the material requirement for coarse aggregate replacement by demolition waste. So here by our literature review, I taken 25% to 35% demolition coarse aggregate, which is indicated by DCA, and we can see that when we use the demolition coarse aggregate, we do not use the demolition fine aggregate. We only use demolition coarse aggregate replacement in such specimens. And when the percentage of demolition coarse aggregate is increased, then the natural coarse aggregate is decreased. Same as before, we use 5% to 15% demolition fine aggregate replacement based on our literature. And here we do not use the demolition coarse aggregate, we only replace the demolition Mold preparation, first we clean the mold and prepared for concrete casting, and the size of my mold was, its diameter was 4 inch and its height was 8 inch. Concrete mix with SST condition, we mixed the coarse aggregate, fine aggregate and required percentage of demolition aggregate, cement and water, and we mixed this with hand. Concrete cylinder casting, when we pour or fill our concrete cylinder, we make sure that there is uniform density and there is no air void. Then the upper surface of our cylinder is labeled by trowel and labeled by the replacement percentage. Curing, we cured the specimen by submerging it into a water tank. In the entire curing period testing, we only use the compressive strength test by UTM machine, and our required percentage specimen was 10. I used 2 specimen for 7 days, 2 specimen for 14 days and 2 specimen for 28 days for each specimen, and I made 66 numbers of cylinders. Here is the sieve analysis data for natural coarse aggregate. Then I found fineness modulus is 6.8. This is the sieve analysis data of demolition coarse aggregate, which is 6.83. This is very near about the natural coarse aggregate. Sieve analysis data for natural fine aggregate, which is then we found that fineness modulus is 2.5. Sieve analysis for demolition fine aggregate, here the fineness modulus was 2.45. I think this is lower because in the demolition fine aggregate there is much more smaller size particles. Here is the slump test data. We can see when we 100% when we use the 100% natural aggregate, then the slump value was 30 millimeter, and it was lower. The workability was very low because we use demolition waste and it has absorbing property, and the water cement ratio was less. Then we can see the compressive strength of coarse aggregate replaced by demolition coarse aggregate for 7, 14 and 28 days. We can see this data by bar chart. Here we can find out that the 30% demolition coarse aggregate has the highest value. This line graph can show us that the 100% natural aggregate value is placed, and when we increase the demolition coarse aggregate percentage up to 30%, the compressive strength is increased. After that, the compressive strength is decreased according to the percentage increase. Here we can see the compressive strength of fine aggregate replaced by demolition fine aggregate for 7, 14 and 28 days. So here we can also see the replacement percentage for 10% demolition fine aggregate. The highest result is obtained. Here is also the maximum result is found at 10% demolition fine aggregate, and after 10% demolition fine aggregate used, then the compressive strength is decreased according to the increasing percentage of demolition fine aggregate. So from my result, I can discuss these topics that the maximum compressive strength was obtained 2400 psi when we do not use any demolition waste, and when we use 30% replacement of demolition coarse aggregate, then we found that the maximum compressive strength is 2954 psi. Again, when we use demolition fine aggregate as the replacement of fine aggregate, then the compressive strength was found 2807. This is maximum at 10% replacement. Conclusion: the compressive strength of concrete using compressive strength increases after 30% replacement of force aggregate by demolition force aggregate, then decrease. This study is relevant to 30% replacement of force aggregate, but not relevant with 20% replacement of fine aggregate, because I found that after 10% it decreases. So I can conclude that we can relevant with force aggregate percentage other research, but not relevant with 10%. We have some limitation in our study that we only use M20 grade and only 0.5 water cement ratio. Other specifications and other water cement ratio cannot be covered here. Raw demolition waste were used instead of recycle aggregate, because in literature review I mentioned that they use recycle aggregate, but I use raw demolition waste aggregate. Recommendation: more replacement persons can be used for further investigation. That was my limitation. Different water cement ratio can be considered. Apart from compressive strength, other quantitative properties like slip tensile test, modulus of elasticity test, durability test, bond shear test can be considered. These partially natural aggregate replace concrete can be used as opposed to the conventional concrete for selected wards where the load is lower, like slab, false ceiling, lintel. Rigid pavement for lower wheel load with proper guidelines. Thank you.